Welcome back to yet another Getting Started with Arduino video. If you're new to these series, this is really intended for folks that are diorama builders, model makers, miniature makers, scale modelers, railroaders, book nookers, maybe even some dollhouse folks out there who want to bring their creations to life using microcontrollers. This seems like an intimidating topic to folks, but it's really not. And so I want to make this approachable and use some real-world examples of how you can use these in your projects. The previous two videos, if you want to check those out, talk about just what a microcontroller is, what the board looks like, bits and pieces on the board, and then the second video talks about powering. Links at the end of this video to some of those. Be sure to check those out if you're confused about sort of the basics there, or new to this, not necessarily confused. I'm always confused, but if you're new to this. Today we're going to talk about basically connecting the microcontroller, the Uno, to our computer. We're going to grab the software, install it on our system, and then we're going to make sure that we can connect to the board and we can write code, write programs to the board. So out of our Super Starter Kit, our Elegoo Super Starter Kit, we're going to grab a USB cable. I need a USB to big old chunky USB to USB adapter for mine. Chances are if you're in that boat, you will already have one of those. And the Uno board. Did I already say we need the Uno board? Of course we need the Uno board. All right, let's keep forging on, charging ahead so this isn't a 6-hour video. Okay, connected to the board. I'm going to plug this into my computer. And what you can see is that the power light is on and the L LED is blinking. And the only reason that the LED is blinking is LED, say that 60 times, is because Blink, a program, has been installed onto or loaded onto the board. This is not blinking because it's connected to my computer. This just because it's powered on. In fact, my computer is right now currently asleep. So let's jump over to the computer and grab some software, show you where you can find that, get that installed, and then we will fire up the software and make sure that we can connect to the board and have a quick little tour of software and load Blink. We'll reload Blink and we'll tweak Blink to make sure that we can start to bend things to our will. And then we'll call it a day and we'll jump over in the next video to something a little more robust that starts to use things outside and off of the board. I think you can kind of see where we're heading with this one, but we want to talk about controlling external things with our microcontroller. So let's jump over to the computer. Now that we are on the computer and connected to the interwebs, where we are going to grab the software is from the Arduino CC site. So you can Google Arduino software or Arduino downloads and it will take you there. So this is the website for the Arduino project. There's a lot of great information here, especially the documentation. We'll probably take a look or pop into that occasionally just so you know where you can get information when you need to know what a specific thing does. Most important here, we really need the software. So we're going to click software. And we are going to grab the Arduino IDE and grab whichever one is most appropriate for our operating system. And I'm on a Mac, so I'm going to grab that. If you'd like to contribute to allow them to continue to do the work that they do, always keep in mind that the Arduino project is actually an open source and sort of member supported project. So if you're interested, you can do that, or you can click download. You can just download. You do not need to provide them with your email address or any of this information. And we're just going to grab that and download it. With the software downloaded, you're going to want to run through your normal installation process for whatever your flavor of hardware, computer, and operating system, whatever that workflow is. So you may drag the application into the applications folder. You might click an installer. You may need to install drivers or grant permission for the device to connect once you have plugged the board in. You may need to allow the software to write to your computer, to the document, to your documents folder. Whatever that normal process that you go through for installing new software and a new external peripheral, you're going to go ahead and run through that. Once that's all done, go ahead and fire up the Arduino IDE software, and you'll be presented with some window that looks something like this. When you boot up the software, it will generally want to open up whatever you were previously working on. So it'll kind of take you back to where you left off, which is a nice little feature. But I want us to all be looking at the same thing. So what we need to do is open up this Blink example. So to do that, we're going to go up to File. We're going to scroll down to Examples. We're going to slide on over to Basics, and we're going to slide on over to Blink. Click that. There are a lot of examples, and one of the beauties of the Arduino ecosystem is you generally can find either in the examples in the software or examples out on the interwebs of most of the things that you want to do. There are plenty of great tutorials out there that will help you do really specific things, and you can go from there. And the documentation on the Arduino site can be very helpful as well. So it will open up a new window. Anytime you open up an example or a previous project and you've got things already open, it will open up additional windows, which allows us to keep our current project open and look at and copy and paste from other examples. So that's a feature, not a bug. And it's nice that these are unique and individual windows that we can work from. However, I already have the Blink program open, so I'm going to close this one up, and let's make sure that we can connect to our board. So this is the first and most important thing, because if we can't communicate with the board, we can't do any programming. So up in this little drop down window, if you click it, you may or may not see your board. In this case, it is saying I have an Arduino Uno that is connected to my USB port. If I select that, I should, if you see yours and you select it, you should be connected to your Arduino. However, let's go through a little bit more of a manual process if you need to manually do a little bit more work to connect, to check and select the right port, and to select the right board. So for that, we're going to go up to Tools. We're going to start with the port. So with your device plugged in, with your Arduino board plugged in, you should, if you go to port, see it connected, see the modem, the USB connection. If you don't, and this is one of the first areas that things can get a little fiddly, if you don't, you're going to go through all of the normal IT debugging process. Unplug the device, plug it back in. You may get a prompt that says, do you want to allow it to connect? Maybe initially when you plugged it in, that didn't stick. If you have, security and software installed that protects your computer, it may want to block that communication. You want to give it permission to connect. If that doesn't work, try a different USB port. Worst case scenario, the age-old reboot the computer and see if that gets it to work. Reboot the computer, reboot the software. Ideally, all of those, one of those, some of those will allow you to finally see your device connected to USB. USB can be a little twitchy because ports can get tied up and be seen as being busy. So that's why trying a different port a different USB plug, and sometimes a bad cable. So a lot of times try a different USB cable. Sometimes the cable can be the issue. Once you see it and you select it, we're going to go up to Tools again, scroll down and look at the board. And we're going to come down to Arduino AVR boards, slide on over and make sure that Uno is selected. Now, in the future, when you start making smaller projects or smaller layouts using a smaller board like the Nano, which is I highly recommend as your go-to initially. There are other boards out there that do other things, but the Nano's a great one. You would want to select the Nano board. And the reason that there are different boards is each one has slightly different requirements and how the software needs to communicate to it to upload programs and to read back information from the board. So we're going to make sure that the Uno is selected. And now to test to see if it is actually effectively connecting, I'm going to slide this output window up. You may not see this output window initially when you first try to upload or you first check your program. This will pop up and it should become visible. So I'm going to click this little arrow, which is the upload arrow. I'm going to click that. You'll see a bunch of stuff down in the bottom right corner. This output window should pop up. There'll be some information here about the sketch, the program that we've written, how much program storage it's taken up, 2% on the board, a bunch of other information. And the lights on the board are going to blink and the transmit receive LEDs will flash. And then the LED will continue to blink on its merry way, the L LED, as it always has, because what was initially installed on the board was this program. Okay, before we go any further, let's do something to modify the program. I've already modified this because I've only done like 6,000 takes of this. Basically, you should see something like this where it says delay 1000, delay 1000. Without going into detail of what this means, and we're going to do that on the next video, change your 1000 to 50 and change the second 1000 to 2000. Now hit upload. LEDs will blink. Now what should happen is your LED, the L LED, should blink really quickly. It should be a little quick pulse. And then there should be a long pause or a longer pause. If you've never done any Arduino programming and this is your first go at Arduino microcontrollers, you can pat yourself on the back. Big round of applause. You've officially written, uploaded, and executed your first Arduino programming. And it literally can be as simple as that. A lot of the things that we want to do are controlling lighting. So think about if you needed to create in a model airplane lights on your aircraft. So flashing lights that are part of the actual aircraft itself, and you need them to blink at a certain rate. It's really as simple as that. This can get really fun really quick, and it will. So we have written our first bit of code. Now let's talk a little bit about what the different areas of the code are and some of the things, the buttons on here, but we'll do more of that as we get into some programming. But I want to do a really quick high-level review so that we can get a sense of how to start to wrap our heads around this environment and what some of the buttons do, and then we'll do more as we move forward. Up in this top section, all of this stuff in gray, these are comments. So these don't do anything. They're a way for us to make notes in the program. It's a way for us to, type in things like credit for who wrote it or where we found it. It can be descriptive. And if it is a / and asterisk, and then an asterisk and a /, this is a multi-line comment. So you could just write and write and write and write all sorts of information in here. And as long as it's between the / asterisk / that doesn't get read as code. It's just a comment. If you see 2 /, that is a single line comment, and we will use a ton of those. These are really intended or used to make notes throughout the program to help us remember or understand or highlight different chunks of things to make it easier for us to kind of visually wrap our head around what's going on. As programs become more complicated and longer, it's sometimes you want to use a comment to visually separate different parts of things just to make it easier. And then comments are also really beneficial when you come back to a project and you're like, what the heck was I do? Why did I do that? It can be a great way to sort of jog your memory on why things were the way they were. So comments, we'll do more of those. Up here in this top area, you may also see other configuration things. So there will be things that find their way up into this top element that are actual code and not comments. More to come on that. Then when we come down into this void setup and this void loop area, the way to think about this programming language is it is generally a procedural language, which means that it goes from A to B to C. 1, 2, 3. Line by line, it steps through the program. Now, there are all sorts of caveats and flavors of that, but basically, the Arduino programming language is really a step-by-step program. It makes it easy to write and easy to understand. So, as the board boots, it goes from the first line and it goes down, and once it hits this void setup, it will run and execute whatever we write in here and do that one time. And it does that when the board is powered on or when you press the reset button. Now, the reason I say that it does this in this little block is a lot of times code will be waiting for something to happen. So it will wait for some thing to initialize. And so it doesn't necessarily just jump straight through it. It may just sit here a little bit until something happens. And then once all of those things do what they're supposed to do, it will drop down into this loop section. Now, the loop section truly is exactly that. It loops through from the beginning line, so in this case, line 33, it goes down to 36, and then it comes back to 33, and it will do this forever and ever, over and over and over again. So this is where the main part of our programming will sit. So the loop. So this happens once. It may have a bunch of stuff that it's doing and waiting for, but then once all of those conditions are met, it comes down into the loop and it runs through and does all of that. Okay, so those we'll do more with the programming. If we go up to the top bar, this little checkbox will allow us to verify. It's a very high level, check the program, make sure there aren't any typos or syntax errors. If we hit the checkbox and everything is right in the world, you will not see any orange messages. If I go and take, for example, this semicolon out and I hit the checkbox, it throws up an error. There's a compilation error. It tells us exactly what it sees. It says it's expecting a semicolon before the curly brace, and it actually highlights it in the code. So this can be, as I mentioned earlier, this can be very useful in debugging. So it gives you some information if you have connectivity issues, but it also gives you code issues. So now it says I need a semicolon right there. If I hit the checkbox again, it compiles successfully. This is our upload button. We did that. There's some debugging in certain boards and certain configurations. This Uno doesn't support debugging, so we won't be using that button. That's okay, we don't really need it. Over here, this will open up a serial plotter window. I don't use the serial plotter a lot, but this will allow you to plot data. So I talked about how the board can communicate back to the computer. These monitors and plotters are where that information coming back can be visualized. So that's what that button does. Over here, this is our serial monitor. That's going to provide additional information. That's not our output. The serial, that's a little bit different. That's outputting from the environment, telling us what it's doing, how successful it's being. The monitor is another way to monitor and actually send information to the board and receive responses back. So we'll use this a little bit to make sure that what we think is happening is actually happening because we can read back and see that a value's changing or something is occurring which we're expecting. So it's a great and powerful tool, and you can access that by clicking the little serial monitor, toggle back and forth. On the left here, this is our folder structure. So this is where we're saving things, and we're able to access our projects that we're working on. Projects are called sketches. So this is our sketchbook, and these are all of our sketches in our sketchbook. You can also go to File, and you can go Open, Open Recent. You can save and save as, all of the normal stuff up here. The board manager, we're not going to use too much because we're going to be using the Uno and the Nano. All the standard Arduino boards are usually pre-baked into the software, but should you start to use a unique flavor of boards, you would sometimes need to install them. So if I wanted to use this Arduino Embed OS Edge board, I would click install to install that so that it becomes visible up in this tools and then board. I would then see it and be able to select it over in the boards. And this boards manager is a shortcut or a menu link item to link to this. We won't really do a lot with that, but that's what that's for at a very high level. We will be using the library manager and libraries. And so the first one that we'll use is probably going to be the Adafruit NeoPixel library. So to find that, we would just type in Neo, because there are a lot of libraries. So maybe NeoPixel. And we would scroll down, and the one that we want to use is this Adafruit NeoPixel by Adafruit. And I already have it installed, but if you need to install it, go ahead and click install, and it will add this library and make it accessible to us. Now, the way to think about libraries very briefly is it is a lot of code written by people out in the world to add deep functionality to the ecosystem, to the Arduino ecosystem. So this allows us to use a library of very complex functionality that other people have created and use it in a very simple way. So our code is very simple, and they've done all the complex work. So very smart people help us who are just starting or who don't want to spend the time to write hundreds and hundreds of lines of code to build a library to do things. So there are a lot of great libraries out there. The NeoPixel one's a great one that we're going to start with. And so you would install the library there, and then later I'm going to show you how we use those libraries. And that's what that's for. This is the debugging link. It doesn't do that because this board isn't supporting debugging. And then this is a find. We could use it to find things in the code. Pin mode, it allows us to search for things in our code if we're trying to find something. There's also a search and replace, which we can use a lot if we're trying to change a bunch of things throughout the code. We'll look at that down the road. Again, all the sort of the normal things that are accessible here. The big ones we'll use, verify and compile and upload up in the menus, are available in buttons. So we generally don't use those. We'll use copy, paste, find and replace. So there's our find next, and we'll do some stuff there. And save as, all of the normal stuff. The most important thing though, really, that you'll want to be familiar with and know how to access to connect your board is under tools, and then board and port. Those are the two big ones. And then the next really big important one to fiddle with to add additional powerful functionality will be the libraries and the library manager. All right, so let's wrap it here. We're gonna use we're gonna start with Blink again, and we're gonna use that to build upon for our next video and next project where we start to control more LEDs, more external components using our microcontroller. So we'll do that here in the next video. Be sure to hit that like and that subscribe and the bell, all that good stuff. We're going to start actually doing really real stuff now. So we'll get away from this is what this is and this is what it does and let's look at the software, into, hey, let's go make a thing that does something. And then you can go and run with that and start to do interesting things with your personal projects. So thank you for hanging in there again. These videos can run long. There's a lot that this does. There's a lot we can cover, and we're kind of at times just even scratching the surface. So I do appreciate you sticking with me through the videos. Again, we will see you back. Thank you again, and I look forward to seeing you with another random making encounter.